present to you Hamid Silatani of Uptime Labs, who is going to explain a little bit of what he discovered when he decided to try and investigate how you can look at incidents many different ways in many different organisations and what makes a difference between them. So,
great. Thanks, Arthur, and thanks BCS Asset Management and IT
Service Management and IT
Asset
Management Specialist Group.
Specialist Group.
Yes.
I got the name right. Almost.
It's fine.
Okay. The photo of this squirrel in the snow is from this morning. No, I'm joking. Been there before. As Arthur introduced, my name is Hamid Silatani. I'm co-founder and CEO of Uptime Labs, but I'm really a software engineer, for as far as I remember. And last 20 years, my job was either breaking complex mission-critical systems or fixing them. So I was within incidents, one way or the other. I understand we have audience online as well.
Yes.
Hello, online at the same time. So if you have seen or watched Groundhog Day movie, you're probably same as my age or older, or if you haven't, you're younger than me. It was a brilliant movie. Today I want to take you through an imaginary journey. Close your eyes, follow my word, and trust me. Perhaps don't close your eyes. I don't want to be. There's a health and safety risk. Keep your eyes open, but imagine this story. Imagine you're an engineer working for a successful online retailer. It's the last quarter of the year. Hitting your revenue target this quarter is very important.
This meeting is being recorded.
It's 6 o'clock in the morning. Your alarm clock goes off, rudely drags you out of your sweet dream. And while your brain is waking up, you realize that it's a Black Friday day. It's a crucial day for revenue targets. Everything has to go very well, smoothly today for you to hit your targets. And indeed, it starts very well until it's not. So start seeing people just humming and trying to, what is going on? And before you know, it blows up to a full-scale chaos and incident. And you're watching all of that unfold before your eyes. After half an hour of panic and chaos, finally, things get back to order and business as usual. You just observed a major incident unfolding before your eyes. What have you learned? Fast forward 24 hours. You're working for a successful online retailer. 6 o'clock in the morning, your alarm clock goes off, rudely drags you out of your sweet dream, and while your brain is waking up, you remember that it's a Black Friday, a very important day for your business to hit their revenue target. And you know the rest of the story. Starts well, an incident unfolds, a major incident. You see engineers and incident manager be different set of people working frantically to fix the incident. What have you learned? Fast forward 24 hours. And don't worry, I'm not going to do this to you. But imagine the same thing happens 18 more times. And if you're still in your sane mind, what have you learned observing people resolving major incidents? What have you learned about incident response? I'll leave you with that thought exercise, but later on in this presentation, I'll tell you what we learned observing people responding to the same incident over and over again. Chapter 2. Learning how to respond to incidents is really hard. Incidents by nature are complex. There's human involved, there's technology involved. Our systems are increasingly complex. Human and technology today in the systems are intertwined. It's very difficult to tell where the technology ends, people part begins, and even that boundary changes all the time. And if that complexity isn't enough, every incident is different. It's impossible to experience the same incident twice. It will be a different day, it will be different time of the day, the market condition will be different. Even if all of that is changing, there will be different set of people involved. The software is constantly changing thanks to continuous delivery. And again, if you manage to get all of that exactly same, the fact that you have seen an incident before, your mental model is different. So it's impossible to experience the same incident twice. And unfortunately, we can't jump on a time machine, go back in time and experience the same incident twice. That leaves us with not being able to answer very important questions. Questions like, what if I escalated sooner? What if instead of SEV 1, we signed a SEV 2 severity? What if we involved team A instead of team B? What if we had a different monitoring tools? These are very, very important questions that is really, really hard for us to answer. Chapter 3. So I'm conscious that I've dashed all your hopes on learning how to respond to incidents. But it's not that. There is while it's impossible to experience this exact same incident twice, but we can get very close to it. And that was the mission we set ourselves at Uptime Labs to achieve. We use a technique called stage work. Stage work refers to a controlled, simulated environment crafted to replicate and mimic real-life scenarios. It's often used to observe skilled professionals dealing and responding to anomalies. So it's a study environment. It's not choose your adventure type of game because the path is very clear over there. It's not Dungeons and Dragons because it doesn't feel realistic. It has got certain characteristics for it to be successful. So I'll expand on that a little bit now. First of all, it's a simulation of a real life event. Second, it has to feel realistic. And this is the hardest part because you can't replicate all the details of the real life because then you will be recreating the world. So where do you balance the trade-off of bringing enough fidelity to the stage work? So that enough fidelity is very important. It's specifically designed to elicit certain skill sets. So in our case was an IT incident response. And finally, which is the most important part of it, is there is no one solution. There are multiple ways to fix the problem and an incident. And that makes it really interesting human experience. So how did our stage work look like? We selected 20 incident responders with various levels of experience deliberately from juniors to very experienced people, welcome, across different organizations and different sectors because they work differently. Then it came hard part of choosing what is enough fidelity for us. So very soon, early on, we realized that software engineers or sysadmins, they are very picky. Okay, everything should add up. So you can't emulate a system. It has the whole tech stack should make sense because they will open the command line, dig into all the details, and everything should make sense. So we ended up creating the whole tech stack and making the platform available on the internet. So this virtual platform, which was an online retailer, when it breaks real in internet, and it's very obvious. And all the systems behind it are real. The second thing we realized was engineers loves their tool. They're used to using observability tool for their work, and without that, it wouldn't feel realistic. So we had to recreate and build in realistic tools that people are familiar with and they can use. but talked about incident and systems being combination of people and technology. So the people element was very important. We had to recreate the social aspect around the incident. And this is where it actually makes a whole difference between a lab environment and a simulation. You can get a problem, broken system in a lab, work on your own to fix it. It feels totally different. When you have the social distraction around you, your boss, senior management distracting you, what is going on? What is the ETA? Customer success. I need to go back to customers. What do I tell them? Your fellow engineers with different ideas of what the problem is, or someone that, no, it can't be my change. Look out elsewhere. So we ended up creating all that environment, leveraging AI and human operators. And finally was communication tool. We realized that it has to, again, be very close to what people use in real life. So we used Slack for that. That was a hard part. Now we have almost all parts, most part of our stage board in place. Then it comes the fun, the scenario itself. So this image really captures our incident scenario. These plates are broken, but not broken. It's called latent condition. So many things in place. The glass have a part to play, the latch of the door, the person who opens the door, and how high the cabinet is from the floor. So many different aspects here. Let's look at our incident. So it was inspired by a real life incident. The reports start coming in, relatively minor, only 2 regions affected. People are not able to buy products online. So it starts seemingly something that, okay, let's look and see what is going on. As time goes on, becomes more serious, more customers are reporting the problem. Engineers start scratching their head. It doesn't make sense. It's like a huge moment of uncertainty. Nothing adds up. It could be currency service, but that service hasn't been changed for 24 hours. So people are scratching their head. Then someone realizes that, oh, there's an error in the logs. API key failures 401. But that also doesn't make sense. There wasn't any change on the API keys in the last 8 hours. So it's getting really stressful and uncertain. And while people are scratching to figure out what is going on, Jack on the other side blissfully enjoying his coffee when he 20 minutes ago refreshed cache. And he didn't raise a change for it. Why would I? I refresh cache if it wasn't every morning. It's a normal operation. No need to raise a change. So he couldn't really connect what he did with the incident that was going on. And it was that refreshing the cache which got the faulty API keys from pushed faulty API keys from cache to the servers, and everything broke. But eventually, 25 minutes later, incident is resolved. I didn't ask if people in the room have been involved in incidents response, and if you have, this scenario may seem familiar.
P1 on Friday.
Yeah,
Yeah.
it happens quite often.
The one thing that's perhaps missing from a simulation is pressure. You should be panicking at some point. You know, should have somebody on your back saying, "Why haven't you fixed this already?"
And trust me, people were panicking.
Yes.
Because that's the social element.
Yeah.
The CTO and CTO here in the org chart was in the back of people. When is going to be resolved? We're losing money by minute.
Yeah.
So, what we learned. So this was the fun part. 13 of 20 participants, they managed to resolve the incident within 25 minutes time window. But there was no correlation between people's experience and resolution time. There were people with less experience which resolved on time, but people with more experience, they necessarily didn't manage to resolve the incident on time. And that tells us the important fact because, first of all, you can't judge one's skill set based on one incident. But also, as Dr. Richard Cook said, good result comes from experience, experience comes from bad result.
We have a chat. Someone had commented in the chat when you were asking earlier, and the gentleman here talking about pressure, because you can't see the chat.
Yeah.
I can see it, yeah.
Okay.
And so I'm just relaying that.
Go for it.
So they were mentioning, no one knows what's actually happening, and there's plenty of pressure. He's taking on the.
Yeah, exactly. So, in other words, everyone did well. Then it came the fun part of going through gigabytes of video and chat logs to understand what people really did and how they dealt with the incident. So we ended up borrowing a concept from John Allspaw. There's a reference to the talk. It's a brilliant talk. I recommend you watch it. That broadly categorizes people's activity during incident response into 4 categories of diagnostic, therapeutic, recruiting, and status and reporting activity. So I'm going to delve into each one of them right now. Diagnostic. Diagnostic activities refers to observing all the signals that during an incident come your way. The first observation was the sheer number of signals that comes towards the incident resolver is just beyond human scale. These signals come from your systems, various different metrics, CPU going up, down, memory, traffic. They can come from actually, before the incident, things that people remember. Oh, 3 months ago when we had this incident was related to load. So that's a signal. It could come from customers outside of your organization calling in, I have a problem with this load in my cart. And it can be completely out of your control. So I have a really amazing story here. Just after CrowdStrike incident, I was interviewing a senior executive about how they dealt with their incident. And he was talking about his ordeal where they walk into the office, their system were all in trouble, not working, blue screen everywhere, engineers working around the clock to work out what on earth is going on. And unbeknown to them, other group of people were amazingly watching BBC News talking about CrowdStrike and impact it had on in the systems, and just the engineers who were trying to fix the issue, they were not aware of what was going on, so they missed an important signal. So this signal comes from various different places in various different forms. One very interesting observation was, while everyone had the same briefing on how to decide about severity of the incident, we ended up with a beautiful selection of different severity. So everyone, 8 people believe that's a SEV 1, 8 people believe that's SEV 2, some believe SEV 3. So there was not consistent view on what the severity of an incident should be. But what was more interesting was that it really didn't matter. So we couldn't see a strong correlation between time to recovery and SEV 1s and SEV 2s. What we observed though was people who spent a lot of time arguing about severity had less time fixing the incident. Don't argue about severity, it doesn't really matter. Second group of actions, therapeutic activities. So that refers to all the intervention that incident resolvers make in attempt to fix the issue. And the key word here is attempt. There is no confidence during the incident that if I do this, do this restart, it will fix things 100%. No, it's just various levels of confidence, but there is no certainty. So examples of therapeutic actions is rolling back changes, restarting service, or rolling forward. Now, in our incident, the issue seemed related to people trying to buy. There was a change in a service called currency service. it kind of intuitively made sense they might be related, but there was absolutely no time correlation. So people didn't know if they have to roll back or not. But many people decided to roll back that change. They did roll back, but nothing happened. It didn't improve the situation at all. Did they waste the precious time of the incident? Did they make a mistake by deciding to roll back? It's hard. Sorry?
They eliminated a cause.
Yes, it's hard to say, but what we realize, the people who rolled back, they immediately learned something. They got a new signal that others didn't, and that was this change was not a contributing factor to that. So that's a very important characteristic of therapeutic activities, because the moment you take that action, it becomes a diagnostic. It becomes a valuable signal for you. And sometimes when an incident is stuck, you just got to do something. So that was really interesting observation. Those people who rolled back, yes, the rollback didn't change, but they knew something that others didn't know and helped them to progress the incident. The third group of activities are recruitment activities. So this refers to getting people with expertise and authority that can help progressing the incident and resolving the incident. We use our internal tool to analyze people's interactions in the chat. So the graphs you see here, there's obviously the x-axis is time, and each bar shows a communication, an interaction between people in the incident. And the thickness of the bar is the duration of that interaction, and color of the bar reflects who they interacted with. It was very obvious for us to see, oh, there are clearly two groups of people. We called them solo artists and band members. So solo artists were the type of people that they took all the burden of the world on their own shoulder. It's my problem, I'm going to fix it. They struggle trying to fix the incident. They play role of incident manager and at the same time troubleshooter, trying to make changes. They had a hard time. Band members, however, on the other hand, they were very vocal, asking for help, getting people involved in the incident, asking opinions, and they had a better experience during incidents. One thing we didn't do, and I massively regret, and for future experiences we will do, we didn't ask people about their stress levels during and after the incident. Had we done that, I think there will be a strong correlation between solo artists and really dreadful incident response experience. The other thing which was obvious we observed during the experience was during incident response, people's mental view of what is going on is constantly diverging. Everyone starts having their own ideas and their own different theories. And it's very important that actively resolvers try to bring those views together so everyone works based on the same idea. Sorry.
With this particular one, did you see a reduction in the time to actually resolve between, because solo artists would obviously sounds like they would take longer, anecdotally. Is that something you saw in the evidence that they took longer to solve it than the band members, or was it roughly the same? It was just better communication.
Very good question. So we didn't see strong correlation, partially probably because of small sample size. But we observed that solo members were more stressed during incident response. I suspect if we do a bigger sample size, which we will do in future experiments, the band members will have better experience. I mean, if you think about what is a perfect incident, the perfect incident is someone, you know exactly what is wrong, wanting to change, do it, and fix it. And if you're a solo artist, that works best. Okay, but how often that happens? So a couple of examples of that, actual examples from drills that people involved others in resolving incident and trying to group think. The last group of activities is status and reporting activities. So this refers to all the actions that you do to keep the stakeholders in the incident updated. Incident response is like there's a small group of people within the ring fighting to fix the incident, and there are much larger group of stakeholders watching from outside. Each of them very interested in what is going inside the ring for a good reason, but those reasons are not related to fixing the incident. Okay, it could be compliance officer. Oh, do I need to report it? It could be CISO. Can this turn to any security incident? It could be CEO. What it means for our end of quarter results. Customer success services. What do I tell to the customers? So they all have legitimate reasons to know what is going on. But as for people who are trying to fix the incident, status reporting and keeping people outside the ring updated is a very hard trade-off, because the time they spend telling everyone else what is going on is the time they cannot spend on fixing the incident. And we did observe that trade-off. The reporting activities, they're entirely different activities to fixing the incidents.
If it's a seriousness, though, that gets press coverage, you may want to be looking at the impact of the incident. Maybe a paper saying that you're an incompetent IT team and you shouldn't be doing your insurance for this particular company. So the incident may be bigger than just the physical defect. It may also be the bad publicity and so on.
You're absolutely right.
And if you don't fix that,
Yeah.
you don't fix incident.
Yeah, you're absolutely right. But taking care of that PR wouldn't make any difference how quickly you resolve the incident. So the point I'm making
slow you down because you might spend more time on the PR side of things than you do on fixing incident.
Yeah.
And that might be good value. If you don't end up in the papers as being examples of an incompetent team.
Yeah, you're right, but it's a different thing to fixing the incident.
Yeah, oh yes. Yeah.
So what we observed here, there were a group of people who sidetracked by CEO and CTO asking what is going on, and they just wanted to keep them informed and appease them. So that stakeholder appeasement, it meant that they have less time to fix the incident. That definitely resulted in longer recovery time. And there were a group of people who decided consciously that, you know what, I'm going to ignore on my intervals, I'll give precise, concise update and wait for my next update. And they had more time in fixing the incidents. This particular example piqued my interest. Probably the participant borrowed it from his real work. There's so much packed in this incident update notification. Let's go through it. The first one, when I'm sending this update, it refers to an incident that how people know it in an organization. So everyone knows, okay, this is the incident that affecting Japan and Turkey. Then there's a reference number. If you're interested to know more about this incident or follow what's happening, that's the reference number. Go and subscribe and look into it. The current status. This is all I know at the moment. If you ask me 10 more times, I can't say anything new. I can make things up, but it won't be useful information. And by the way, entertaining you takes my time away from fixing the incident. Yeah. So read this and stay away. And finally, next update is a polite way of saying, get off my way, back, let me fix the incident. So it was just astonishing how much is packed into one simple template. So in summary, incident response is a huge cognitive load on people who are trying to fix the incident. They're dealing with uncertainty, they're constantly distracted, and if they can't manage that cognitive load, it's going to be very painful and lengthy organization. And it was pretty obvious in our experiment that people were using different techniques, leveraging other team members to help with coordinated efforts, or some reverting back to the muscle memory they have developed over years. First, I'm going to quickly check the changes, declare an incident, send comms out, without even thinking about it. So that came very handy. On the other hand, spending too much on deciding what the severity is, added to that load, didn't help, or trying to keep stakeholders happy, again, didn't help, took valuable time away. So, what is next for us on this series of experiments? There were two limitations with our experiment. First, everyone taking part, they knew that there's an incident. And that's not real in real life. You know, you don't go to work knowing that 10:15 there will be a major incident. That never happens. So that affects the study. Second, real incident response is a team of human working together, not one human and everyone else AI. We try to make it as realistic as possible, but there's a limitation there to be aware of. What we are planning to do next year, first quarter, is to run Team Groundhog Day. So the same, similar experience, but more than one real-life participants. We will be running experiments with no time limit. What if people don't know they have only 25 minutes? Would it make any difference? They know that it's important, but they don't know that there's a time limit of 25 minutes. So I think that would be interesting. And finally, involving folks from different roles that are involved in the incident. Customer services, CTO, CISO, and observe their behavior. At the end, I want to leave you with one simple quote, 4 words, but it took me 4 years to really grasp it, and I'm not sure I'm grasping it, from Professor David Wood. Resilience is a verb. In other words, it's something that you do, not what you have. We have built layers and layers of defense in our technology and in our processes over time. And these layers of defense successfully preventing many incidents that could have happened. But one day that these layers fall one after the other, and you get an incident, and we all know that happens quite often, it comes down to your team's ability to work effectively together under uncertain situation to save your business. And that ability only comes with frequent practice of dealing with emergencies and being thoughtful about building skills like reducing cognitive load. Those only come with practice. These practices you can gain either by real life incidents or by simulations. I suspect simulations is a cheaper one than real life incident. And that's one thing, one example of what resilience is.
So the challenge I have with that last statement, if you're working in an IT support team, incidents happen, so they are cheaper. Yeah. Simulations require cognitive load and organizational energy to make happen. And that's what I find with most of the organizations I work with. They like the idea of doing simulations, but they're not easy enough to pick up and run with. Whereas if you just wait for a major incident, it's going to happen anyway. Yeah. And then you get to practice. And so that's what normally happens, is that it's done through reality rather than done through simulation.
Yeah, and that's a very, very valid point. It happens in real life, it will be expensive. And that really resonates with my own personal experience when I left my job to start Uptime Labs. Yeah. Running simulations is hard. You need really solid people, engineers, experience to think of a scenario. Then you need to take a staging order, staging environment, how to replicate it. Then good luck with aligning calendars to get people on it at best. If you really want to do it, you do once a month, and let alone then debrief afterward. So what we did was we were going to make running simulation 100 times easier, seamless, where you can run it on your own or as a team whenever you want, without any dependency. And that reduces costs of. Okay.
Yeah.
If there's a simulation you mean it's a special software or it's a system that manually created by some simulating tools.
So the simulations we ran here, we use our own platform.
Okay.
Which is, for a better word, is a kind of a metaverse. The experience for user is as if you're working for a company remotely, and everything else feels very real. So you just turn on.
So the simulator itself is embedded in your system?
No, it's outside of your system.
Out of your system. Yeah, but you have some interface so that the simulated event can be injected into your system.
So it's
trigger some panic.
no. So we're not creating simulation within your environment.
Okay.
It's entirely isolated, different. It's not even replicating your environment.
Okay.
And the reason for it is, I mean, when we started the business, we thought we have to do it.
So it's not kind of drill. It's
But what we realized that the skill sets that people really want, A, they're transferable. Okay, it's not dedicated to one specific environment. B, it's mostly soft skills and technical skills. Okay, decision making, communication, and coordination. And for those, it's even better if it's done in an environment that is very different because it puts people on the edge. You don't have a lot of background knowledge. Familiarity. So that's where we ended up.
Can you look at separating roles so that you have some people whose sole job is to talk to the stakeholders and the regulators and the press and all the rest of it, and other people's job is to fix a problem, and the people fixing a problem just don't have to worry about any of the communication stuff. They just have to do a brain dump to the people whose job it is to be nice to the stakeholders.
Well, that's one of the patterns that I've seen happening, separating stakeholder management from people on the bridge. So people who
Do
actually
you remember David, who used to be on the committee?
Sorry?
David from Belfast.
Yes.
That was what his role was.
Yes, okay, yes,
Yeah.
yes.
And I mean, they named the title of Major Incident Manager.
Exactly.
And it was precisely that. You've got someone who knows what the process is, they know where the templates are, they know all of that kind of stuff, and they keep the engineers away from all of that.
Yes.
So they just go, right, you're on the team, you're on the team, you're on the team, we're using this bridge, so whatever the tool happens to be at the time, get everybody in, and then they sit back and they don't do too much.
And the authority of the incident, if any, let's say CEO bypasses and comes on a bridge, they say, please, go away, this is not your space.
And they can also call shots like if someone like you were saying about rolling back the change.
Yeah.
So in my brain, I'm immediately thinking there's an element of surety I want that I'm not going to make things worse, right? And that's always the trade-off that you have within this scenario. And if you do not have authority, you can feel like you're in a bad position, particularly if you're in a situation where you have a strong culture of following the change process or being shouted at if you don't, right? So if you've got the CEO going, it's fine, do it, it's fine, do it, then whatever your actions are, it's fine. You're not going to get fired or in trouble or anything like this. So these thoughts just disappear out of your brain. And having a major incident manager who's got empowerment to say, fine, reboot the server, fine, roll back the change.
Yeah, exactly.
And they take the decision out of your hands and they,
As part of that is keeping managers away from people, because having a manager telling you you'll be sacked if you don't get something fixed in 5 minutes does not make you fix it faster.
No. There's actually academic research that presence of senior executive on the incident bridge at best is not helping.
Yes. Usually,
So if you
it's
really
definitely
dig it really well,
Yeah.
they won't make any difference.
Yeah.
Any?
Well, machine learning presumably could pick up some of these things that have happened before, because every incident is different, but aspects of each incident are the same. So it might be stuff you can learn from previous incidents that you can just, a simple dictionary, last time this sort of thing happened, it turned out to be A, B or C.
Yeah.
Be quite nice.
What I found with machine learning is that it's really good at understanding basic metrics. So if you know that you can see the processes going up in a particular manner and the memory usage, potentially the disk, then it will actually say, we've got a 70% chance of this particular server falling over. But it's understanding whether or not that server is connected to the front end systems, putting the website up, or literally just running the point of sale system for the cafeteria in the building. Where does it sit in the importance? So yeah, it's a really good idea to have machines available to do these bits, but it's the understanding of what's actually comprising everything that does
It's
the magic.
exactly what you were saying about signals earlier.
Yeah.
I've seen situations where people have got relatively new tools which work out loads of stuff. So now you can see everything. And the problem is you've now got 1 million data points per second, whereas before you only had one error. And the error might have just been like, something failed, and you're like, that is not helpful, but at least you can see it's happening.
Yeah.
And the prevalence of extra noise distracts you. And you end up with logs, and you're just like scanning through here, and it's like it's literally logging every line of code that's running, most of which are completely irrelevant. And then when you're in support, you're rarely, I know DevOps is starting to change some of these things, but you're rarely the person who really understands the system at that level. So having like fine debug on is often really counterproductive. Although it might be the only thing that gives you the signal that you need.
Well,
That gives you the answer, right?
one
And
out
it's-
of million.
and it's trying to process that. So that's kind of what I've seen of all of these tools that provide you monitoring and then embedding in better ways of putting in heuristics or machine learning or whatever it is it's still just giving you a lot of stuff that you really need to know how to ignore. But can say, you know, producing, I've had stuff before, you're like, yeah, you got an issue, you've never seen the error message before, you stick it into Google and Google goes this, and you go, fine, and that's it. You fixed in seconds and you have no idea what you did.
Yeah, I mean, you're touching on a very interesting point. There's actually active research is going on impact of automation on engineering. There was a brilliant talk last month by Courtney Nash, Irony of Automation. And the point was, the more you automate, the more you make engineers' jobs difficult, because they now need to be a lot better engineers. The training that they need is much higher, because automation will hand over things to you when it has tried all the obvious things, okay, without ignoring what it does, and just, okay, I don't know, it's your problem, and yeah, how do you deal with that?
You get
Yeah.
chucked over.
I worked with a support manager who said this exact thing. He said I was much happier when I was out on the road, I was going to customer sites, I was doing the installations, and I had loads of issues to fix. Now I fix one issue a month, and nobody escalates an issue to me if it's easy. You've all tried everything, and then you go, we have no idea, you're the genius, off you go. And you're the support manager, so you've got the ultimate responsibility for it. And he's like, okay, this is going to take a few hours now. Yeah.
Exactly. And the same thing pilots are experiencing. So last year I was interviewing a pilot. There's a lot of synergy between incident response and human factors in our industry and aviation. The only difference is we are like decades behind aviation in terms of maturity of thinking about this stuff. And the pilot is saying that the level of automation in planes is probably far more advanced than any computer systems that you are building. But with increasing level of automation, our training has got more and more stringent and hard. And we always need to know how do we reduce automation to zero and still be able to fly a plane with a zero automation. Can we tell that about today's engineers? They can run a software, operate the software without any of these tools. You know, we got to put deliberate effort in training people and making sure that we know exactly what's going on underneath too.
Also designing the tools, because if a tool is presenting you with an awful lot of noise and you can't fix the problem, that tool has failed. When you design the tool, you should be looking at the potential users, the customers, the support people, and what they need. And quite obviously what they don't need is to be swamped with irrelevant information and trying to fix a problem. So that's a bad tool design. The tool, if you're going to design that, if the tool's going to be useful, it needs to prioritize, cut down to the most likely cause, present just enough information for people to deal with. If that's hard to do, it will be hard to do. Unless it does something like that, the tool is not being much use. You're looking upset at that statement.
No, I'm thinking I knew exactly what you said about it being hard to do. I'd say this is certainly, I mean, it's sort of your classic logging is you have errors and you have warnings and you have informational and you have debug.
Yeah.
And when you get down to debug, if coders have written that well, you literally see every step and you can go, that's correct, that's correct, that's correct. The problem is, it's when it's about 150 steps and that is just a quarter of a second. And what you're looking for is 4.5 seconds away. And now you're on to about 20 minutes of scanning stuff through. And again, if you haven't written the code that does all of those steps, you don't know what that particular system is doing in that moment. And it's very difficult for someone to say the bit of information that's relevant for this particular issue is this thing.
I guess what I'm saying is it's very easy to sell a CTO or a top level manager a tool that will help you fix this stuff, and you don't ever go and ask the people at the sharp end, is this tool actually useful?
Yeah, and that's the irony we're facing, because the tool providers are not necessarily incentivized with quick fixing. They're incentivized with making more money. I've been enough, like let's say in 2007-8, when I was on support and troubleshooting, it was terminal, knowing grep, egrep, few Linux commands. Systems were complex. You could find a way. Fast forward year on year. Oh, now we have PagerDuty. So I need to remember whether I get the alert. Now we have Splunk. Remember how to use a Splunk. Are these servers attached to it? Later on, you have APMs, application performance monitoring. Oh, where this tool connects and where this information. You just are added more and more and more stuff that now you need to know exactly how to operate. Flip side of it, these expensive tools, I actually did a survey last year. I won't name any tool, okay? But observability tools, they're really expensive, okay? They're top line budget, 6 figures, they command 6 figures. Organizations invest in such expensive tool, and then you come and survey the engineers. Less than 10% of them know how to use those tools effectively.
Yeah. And they don't dare admit that, of course, because if they do,
Where is ROI?
they'll tell the government.
Maybe you can set out some mathematical approach in handling this information. Whatever sensor or the observing agent is working, and you perhaps can set up a kind of a time series model for each sensors and try to track their correlation with each other at every point of time in the past. And so you can figure out what the gentleman said about, you can figure out which data is more relevant, but which is not, or maybe
That's the kind of system that you're talking about, right? That goes off and tries to surface the relevant stuff from lots and lots of monitoring tools and lots of data points, right?
Yeah. Just I'm conscious that I might come across a slightly different, kind of wrong. So I'm not against the tool. I'm all for the tools. They're helping. What I'm saying is, tools are not the answer. Don't buy more and more tools. But every tool you buy, also invest in training and making sure it fits within your ecosystem.
Also worry about false positives. Think about looking at general things. People are so proud about all the things they catch. They never tell you about the false positives, the things they catch that aren't really a problem. And if you want to, if the metric is only that you catch every single possible issue, there's going to be a lot of issues you catch you shouldn't really have caught. And that's incredibly confusing, because if it's a false positive, it's very hard to disprove it because there's nothing there. So you find yourself trying to sort of disprove a negative. Sorry, what's the thing you can't disprove?
Negative.
Yeah.
Have you done anything in terms of this point about the investment in training for these tools, in terms of, because you mentioned about people being able to competently use the tool, which is 10% was the figure if I remember correctly. Did you correlate that to do like training programs and how they did their project management? Because you're talking really about cultural change, embedding stuff within an organization, benefits realization from a project management perspective, right? Which isn't quite the same as tool implementation, which tends to be, there's a target, there's a date, and you run towards it, right? And then it's delivered, so that's great, then we can tick it off.
Yeah.
And things like training are very, very easy to miss.
Yeah.
And it's exactly like we're saying about with getting people to do simulated major incidents, is if you're trying to get people to do stuff all the time, the moment you stop them to train them on anything, they're stopping producing So this is a negative equation in many managerial heads.
Yeah, and it's a false economy. So what we did last year, we compared IT with other safety critical industries. I take that many will argue that IT is not safety critical industry. I think otherwise. All aspects of our life.
Yeah,
Sorry?
no, I agree with you, it is
Yeah.
safety critical, yeah.
Yes.
All aspects of our life depends on it. So if you put IT alongside healthcare, alongside aviation, and then look at how much each of these industries invest in people's training on.
And
Yeah.
I put aviation up to transport. So it might be, to transport. So railways are very,
Yeah.
very similar. And oil.
Yeah.
I used to work for Esso, and they had a simple rule that you park backwards in the car park. So when you drive forwards, you can see people who are walking through the car park, and you go at no more than 10 miles an hour. And if you do, you're fired. End of story. There's no messing around in these kind of environments because we can have oil leaks as a consequence or plane crashes or whatever. And it's that mentality which changes things.
Yeah, exactly.
Exactly. But then they always have it in their heads, they have to do the training, they have to do this. If you want to go on the oil refinery, you need a full day's training on how to be on an oil refinery before we let you anywhere near the gates, you know. Same with planes and all of this kind of stuff.
Our pilots constantly they train to deal with engine failures. Okay, they don't have engine failures on every flight, thankfully. But if they get one, they know exactly what they do, and they don't need time to think about it. Let me open my checklist, Boeing, what you say, Airbus, and see what pages. There's no timer, so they constantly train for it. So we looked at the training. It was a huge gap. We looked at certification. Okay, you need to be a certified pilot to be trusted with flying commercial jet. Software engineer. They don't even look into, have you studied software engineering? Can we trust you with production? That is based on what we have seen.
But
people get their hands into production.
I've always
very
said
easily.
that software engineering will be an engineering discipline only when they have to take out insurance against culpability. You know, when it goes wrong, you get sued. Because at the moment, when you get your software wrong, there's no real comeback on you. You might get sacked if you're unlucky to just get another job. But it's not like being a doctor when you get struck off, you can no longer practice.
Yeah.
Software engineers, I think, should get struck off if they design bad systems. It can be shown to culpably design bad systems.
I think that is changing. Regulators are starting.
Yeah.
I mean, it started with financial services, digital operational resiliency.
I can
other
I think the reality is, although you say IT is mission critical, there's an awful lot where you can draw those lines, right? I mean, you could say the automation within a plane is, technically speaking, some kind of IT, right? It's certainly electronic engineering and software, right? So it's got that same basis, but you don't have the direct need politically to drive it. And that's, if you look at like safety, like oil, like airline industry, etc. Someone crashes a plane and people go, why did that happen? An investigation comes out with a report and says there was not enough training. Right, okay. A politician comes in and says, right, that's never going to happen again. You're not allowed to fly unless you've got trained people. Boom, 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 boom. And then the standards and all of the training programs start to flow from that level. But it normally requires people to die first, and then the laws come afterwards.
But people do die from failed software. If they lose their savings, commit suicide, or the incomes, the crash we had in 2008 has killed people who were too poor to heat their homes properly. So a lot of these failures are mission critical. It just also occurs to me that if you buy one of these tools, I would expect in a mature organisation that you see yourself having a problem, incidents take too long to fix or something like that, some metric. And you buy the tool, and then you look at that metric, and after having bought the tool, you expect to see that metric improve. And if it doesn't, you look at perhaps training people using the tool, then the metric improves. But it seems to me that in IT, it tends to be political. You buy the tool, you don't want to see whether it worked or not, because the person who bought the tools, their reputation in the organisation is tied up against the person who bought that wonderful new tool or built the relationship with HP or whatever it was that he did. And so there's a real resistance towards actually seeing whether decisions in IT actually worked or not. And that's the definition of your organisation. And it is why software companies make a fortune selling tools that look great on paper, promise the earth, knowing that nobody's ever going to check whether they work, because it'd be too embarrassing to find out.
That's unfortunately too true.
I wonder if we don't miss any questions online. Is there any?
I put out does anyone online have any comment for those on-prem?
Okay. On that note, thank you.
Right, thank you very much.